notes?
New notes. Adding and subtracting vectors. Tell me you guys all know how to add and subtract scalars. And in telling me, tell me you remember what a scalar is.
Scalar was...
Yes, I know how to add and subtract.
Scalar was the other thing.
Scalars are the non-vector things. Scalars are just numbers. You know what 2 plus 2 is, then you've just added 2 scalars. Okay? Adding and subtracting vectors. So, with vectors it's a little different. I'm going to start geometrically, because that's harder. I'm going to give you the shortcut. So, if I ask you to add the vectors, vector A plus vector B. There's no quick notation for this. It doesn't equal vector AB. Doesn't, but if vector A has 2 components, A sub 1, comma A sub 2. Vector B will have 2 components, B sub 1, B sub 2, right? Okay, geometrically, these vectors are added what's called tip to tail. Geometrically, these vectors are added what's called tip to tail. You can do this by drawing them. There's a faster way, but I want you guys to see what's going on first. Any questions on A sub 1, A sub 2, B sub 1, B sub 2? Just out of curiosity, how would you describe A sub 1? What is that?
It's an arrow on a graph.
Arrow on a graph. What does this arrow mean in terms of vector A?
It is the length. It's the distance between the point and the arrow.
Arrow?
Wait, what?
It's the x-coordinate?
X-coordinate's close. It's not the x-coordinate, because this isn't an actual place. Remember, you can slide vectors all over the place.
But it's like the magnet?
It's their relationship with each other.
Like
Close, close, close.
how long the x value is, or how big it is.
It's called the x component. Excellent. It's called the x component. Who remembers how to find the x component?
Not me.
Not you? Oh, this is sad. This was on the homework.
Yeah, we did this like ages ago.
It
I
was
did
like...
it on Friday.
Alright. Anybody just curious if you remember what's on Friday? This part, Kath said it best. This is the x component. So if we have a vector,
It's like with slope.
here's vector A. You can always make a right triangle, right? Is that correct?
Mm-hmm. Yep.
And this length is going to be A sub 1.
Oh yeah.
This length would be A sub 2.
Now I remember.
I could also have called this A sub x, A sub y. That might have been closer to what your book does. The pre-calc book does it differently, though. So I'm going to
you
mix
square
and match
them
them.
and add them together and find the square root to find the length of the vector.
Yep, everything from geometry holds. And if you know the angle and the length of the vector, then you use cosine to find A sub 1 and sine to find A sub 2.
Did you just nose, like, point me?
I did. And you responded. Don't try to deny it. Okay, so, geometrically, I'm going to say that angle A is 3, 2. Seems to be my favorite vector angle example.
Angle?
I'm sorry, vector A is 3, 2. And I'm going to say...
Wait, did you just make that up, or is it...
Totally made it up.
Okay.
Could have been anything. And I'm going to say vector B is 1, 4. Now, I can draw these anywhere on the Cartesian coordinate plane I want. Remember, vectors are independent of location. That's because objects or particles or things don't care, so to speak, if they're being pushed or pulled. If a force is acting on it, a force is acting on it. Doesn't matter if it's a push, doesn't matter if it's a pull. Okay? So I'm going to choose to draw angle A
Right before, in front of angle B.
Well, I keep saying angle. I'm sorry. I'm going to choose to draw vector A from the origin. 1, 2, 3, 4, 5. Up to the point 3, 2. Okay, that's going to be my vector A.
Why did you count to 5?
Yeah, I don't get it.
You went 3 to the right.
I went 3 to the right and 2 up.
But you went 1, 2, 3, 4, 5.
1, 2, 3, and then I kept going 4 and 5 up.
Oh.
That was dumb. Actually, that did not clarify anything. Now this goes from the point 0, 0 to 3, 2. That was just how I was thinking in my own head, which I should avoid thinking in my own head. Now, here's a question. Vector B, okay, has an x coordinate of 1, an x component of 1, excuse me, and a y component of 4. Now, when you add vectors...
Can you just add the numbers?
Hold on. Slow down, cowboy, slow down. Don't ruin the
It's
suspense.
so awesome. No.
Well, hang on.
I'm not. Everyone.
Stop, Ramsey. Stop, stop, stop. Geometrically, tip to tail. Here's how you do this geometrically, okay? You draw the vectors with the tip of one at the tail of another. So, from this point 3, 2,
Go.
I need to go to the right 1
And up 4.
and up 4.
Epiphany.
Okay?
Are you kidding? This is the greatest thing ever.
So that's vector B. Ramsey,
Wait, oh.
where did we wind up?
We wound up. I don't. 6 places up and 4 places to the right.
Correct. So the result... Now, well, first thing, let me go back. Let me finish the geometric part. Okay, first. The resultant vector, okay, which is usually, in some books, it's called R. The resultant vector will go from the tail of the first vector to the tip of the second. It doesn't matter what order you draw them in. If I had drawn B first and then A, I would have gotten this followed by this. Would have gotten a parallelogram.
What?
Nice.
So it doesn't matter if you draw A then B, B then A, or both. Okay? The resultant vector is going to go from the tip of one to the tail of the other one. It's also going to be one of the diagonals of that parallelogram. That's all the geometry that's going on. Yeah, I apologize. It's not my best drawing.
But why did you make that? Oh, okay, I get it.
So this diagonal is the resultant vector. This diagonal is the resultant vector. Okay? And Ramsey thinks that we will wind up
Ramsey knows.
having moved a total of 4 to the right and 6 up.
He's lying to you.
And he is correct. The resultant vector is going to be 4, 6.
You just need to add them.
Pardon?
You just add them.
Correct. You just add the components.
Yeah.
Okay? You just add the components.
Wait, what's R? It's just like the right? Or
I'm sorry?
R vector
R vector is the resultant.
of result.
Is usually called. The resultant vector is the vector that results when you're done adding up all your forces. Or subtracting your forces. Forces can go in positive and negative directions. This can also be written... May I erase this board?
Yes.
What?
Okay. This can also be written in I and J form.
I and J.
Yeah, remember, what is... If I write 3i plus 2j,
Oh. Right.
remember I is your unit horizontal vector, and j is your unit vertical vector.
Now I'm getting bad memories. And then with like I know there's like really strange stuff we're doing with I and J later, and I hate it
Yes.
with a passion.
Well,
I don't hate it.